Assalamualaikum and good morning. Today chapter 7, bolted and welded steel connection without eccentricity. So types of connections. The connection are needed to join member together in trusses and lattice girder. So macam if let's say you ever look at any steel design kan you nampak macam yang ada lattice girder yang macam like 3D. How do I draw this? Dia ada macam ni, and then dia ada macam ni, and then dia panjang lah. Salah lukis. Okay, never mind. Something like this. Okay, so you nampak dia macam ada bersilang besi. So inilah contohnya lattice girder lah. Lattice girder can be in many design, macam-macam design dia ada. So dia ada sambungan-sambungan lagi. So ini sambungan ni daripada one member to another one member. Dia akan pakai because of this is steel element, so dia akan pakai steel connections. Okay, so plates together to form a build-up member. So if let's say you have plates, okay, mungkin you nak combine with I-beam. So you have I-beam lah. I-beam how do I draw this? Okay, I-beam so you want to combine with I-beam. So you will use steel connections, beam to beams, trusses, bracing, etc. and columns in structural frame. So you now combine between all these elements and columns to foundation. So this one, if let's say column, it is still column, and then you have a foundation. So foundation ni tak semesti it can be steel foundation also kan, because of your other steel footing also. Okay, so you boleh combine dengan menggunakan steel connections. This is contohnya lah. So internal truss joints. So you have like trusses yang you nak joins together between like one plates and ada all the elements of truss yang lain-lain and then we have brackets, beam connection contohnya because you want to connect between this I-beam on one side and the other side of beam yang lain, you nak connect together as a column base. Okay, and then the ordinary bolt. So the black hexagon head bolt shown with nut and washer is the most commonly used structural fastener. The bolts are into strength grade as specified in BS 4190. So here if you look at the bolt, so yang this area we call it as shank. Hilang pula. Okay, this is the thread. So tensile area will be at the thread area and then the nominal diameter kita akan tengok pada shank. So mostly kalau dia kata size of bolt tu adalah size shank ni lah, maksudnya diameter shank ni berapa, itulah nominal diameter dia. And then the length is from the shank, daripada atas shank sampai ujung thread. Since tadi I cakap dia ada dua grade, which is grade mild steel and high tensile steel. So kalau mild steel, the yield stress is 235, meaning dia boleh support as much as 235, and if it is high strength steel, it can support as much as 627 Newton of mm square. So the diameter, the main diameter used are so 16, 20, 22, 27. However, size yang dalam bracket ni is not preferred. The nominal diameter of hole for ordinary and greater than the bolt. So barulah dia punya hole mesti bigger than the size of the diameter of the bolts. So if let's say sampai up to 22 mm, maksudnya daripada 16, 20, 22 ni you tambah 2 mm untuk diameter dia. For example, kalau 16 mm bolts, okay, so diameter bolts so hole dia akan jadi 18 mm because of you tambah another 2 mm. Okay, so kalau 22 mm diameter bolts, hole become 22. If let's say 22 mm diameter bolts, the hole become 24. Okay, but up to 22 saja. So start daripada 24, you kena add another 3 mm. So if let's say 24 mm diameter bolt, so hole dia akan jadi 27 mm. You kena tambah 3 mm. If let's say 27, then jadi 30 hole. And if let's say 30 mm diameter bolts become 33 mm diameter hole. Bolt may be arranged to act in single or double shear as shown in the figure. So this is single shear. So for example, you have two plates that you want to combine together. So you akan letak bolts dekat dalam ni lah. So this is the hole So this is side view. So ini plan view. So you tengok dari atas macam ni lah. Okay, this is like cross section lah. You potong. For example, you cut here. Okay, you cut here. So this is the cross section dia. Okay, and same goes with the double shear. So double shear, if you look at here, yang mana satu sebenarnya yang you nak combine. So ini dua-dua ni adalah member plate So this one we call it the one yang kita nak connect together, we call it as member plate. Okay, so same here, if you look at ni macam sandwich. So yang dekat tengah ni 1 dan 2, this is member plate. Okay, however, the one yang at top and bottom, this one we call it cover plate ataupun splice plate. Splice, S-P-L-I-C plate. Okay, so the kegunaan cover plate atau splice plate ni sebenarnya you just nak boltkan dia together so that these two member will combine. Okay, so ini dah kita panggil dia double shear and this one is single shear. If let's say, this is sama jugalah. This is plan view and this one is the cross section view. So for example, you cut it here. Cut kat sini. So you akan nampak daripada depan, you akan nampak from this view. Okay, so you akan nampak macam ni lah. You dah potong dia. So you nampak macam ni. Okay, so this is the hole. Spacing akan daripada centroid bolt yang you letak ni ke centroid yang sebelah dia. So itu spacing. And distance daripada centroid of this, the bolt yang paling hujung ke hujungnya lah. Okay. And then we have edge distance. So edge distance yang this one daripada centroid to the end here. Okay, so this is edge distance and distance spacing. Okay, so when you design, you kena tahulah which one is spacing, which one is end distance, and which one is edge distance. Provision for spacing edge and end distance in normal conditions are, so the minimum spacing is 2.5 meter times the bolt diameter. So okay, so I buat example So example, so you have a bolt that size is 20 mm. Okay, so minimum spacing. So spacing kita tengok balik spacing yang mana daripada centroid first bolt sampai centroid the bolt next to it. Okay, so itu adalah spacing. So minimum dia paling kurang tak boleh kurang lagi pada value ni. So it should be, spacing should be 2.5 darab dengan diameter of bolt. So minimum spacing. Okay, so 25 times 20 you akan dapat 2.5, you akan dapat 50 mm. Okay, so spacing tak boleh rendah pada 50 mm. If let's say you letak 45 mm, so tak boleh. Okay, so mesti at least 50 mm. The maximum spacing in unstiffened plates in the direction is stressed at 14 T, where T is the thickness of the thinner plate connected. For example, the thickness of plate adalah 25 mm. Okay, senang cerita, for example, it is ada double shear So contohnya, so you ada, this is double shear. Okay, so ini satu, ini 25, satu lagi 30. You akan ambil size yang paling the thinner plate connected. Okay, so plate yang paling nipis. 25 adalah yang paling rendah. Maximum spacing should be 25 mm darab 14T. Tulis 14T. So which means 14 times 25 mm. Spacing you mesti antara 50 mm ke 350 mm. Okay. So this one for spacing. So you can put any number between this lah. And then you have another one, the minimum edge. The minimum edge and end distance from a roll pula. Betul lah. From a roll machine flame cut or plain edge is minimum edge and end distance is 1.25D. Okay, where D is a hole diameter. So have the example. So kita pakai example. Maksudnya kita pakai data yang sama. For example, so diameter hole bolt adalah 20 mm. So bila diameter bolt, so this is, so hole will be 20 mm plus dengan 2 mm. Masih ingat ya, sebab kita dah ada this one. It says that when it is 16 sampai 22, kita kena tambah 2 mm for diameter of hole. Okay, so that's why plus 2 mm. So it become 22 mm. 1.25 tak darab dengan 22 mm. 27.5 mm. So this is the minimum edge distance. Okay, and then the other one is, so the maximum edge distance is 11T constant. Okay, where constant is 275 PY 0.5. Okay, sekarang ni kita tengah buat untuk plate kan, where constant, so PY ni steel strength. Ini mesti steel strength untuk plate, bukannya steel strength untuk bolt. For example PY is 155, sorry. So PY for example is 155. Take the constant equal to the formula of 275, divide by PY and use square root. Then you will get 1.332. Okay, so next we're going to use the formula of maximum edge distance. (11TE). Okay, so T again we use the similar one as the example that I put here. So T is 25, so 11 times 25 mm, and you just times the value of the constant. The constant is 1.332. Okay, so you will get 366.3. The minimum edge distance and also the maximum edge distance is between 20, what is this again? 27.5 to 366.3. So it shouldn't go below the 27.5 and it shouldn't exceed 366.3. This is how you're going to calculate the spacing, edge and end distance. A shear joint can fail in following 4 ways. So there are 4 shear joint failure: by shearing on bolt shank, by bearing on the member or bolts, by tension in the member, and by shear at the end of the member. We're going to look at one by one. The first one, which is by shear on the bolt shank. Shearing on a bolt shank, what happened here, you see that the bolt is breaking. Maksudnya dia is breaking into 3 pieces lah, senang cerita. So this is like 3 pieces of, so bolts ni pecah. So because of there is a force that pulling this plate and here also pull it out. And in single shear also is about the same lah. So you see that there is a break between the bolts. Why this happen? Basically for modes 1, so this is mode 1. I should write it here. Okay, shearing of bolt shank. Provide sufficient bolts of suitable diameter. So because of the diameter is not suitable, maybe the diameter is too small, this caused that the bolt to break into pieces. So that's why we have to provide suitable diameter of bolt when we design for the steel connection. And the second one, we have bearing on plate and bolt. Bearing on plate and bolt is also the same because you didn't provide suitable diameter of bolt. Bearing is a stress that happen between, for example here, kalau steel connection you have bolt and then you have the hole here. Bolt jadi nipis sangat. You have bolts and then you have a hole. This is bolt and this is the hole. So perhaps if you didn't provide, mungkin dia terlampau besar, maybe the bolt size is bigger and you don't provide the suitable diameter of hole for the plate. So what will happen when there's a force that acting on this, sebab dia terlampau besar, is not suitable for the hole, so dia akan tarik. Or perhaps when it is too small, bolts tu dia free to go left and right and up and down because there is a space that doesn't fit the hole, so dia pun lebih senang bergerak, and when there's a force pulling it out, the bolt will akan tarik sekali the plate. Bolts ni yang akan crush, pecah. And the third one we have here is design tension members for the effective area. So when this happen, you have to design tension members for the effective area. Tension failure on the plate. What happened here? The bukan bolt yang pecah, but plate ni yang break into two. Probably because the plate don't have enough strength to resist the force that pulling it out. Because of here, it says that for mode 3, design tension members for the effective area. So for the effective area, this one, supposedly the effective area is this place lah. So when there is a force and you don't provide enough strength for the steel to resist the force, so steel you akan pecah between these two. And also if you don't provide enough thickness because of strength against shearing is affected by the thickness of this plate. Area dia tak cukup, strength dia tak cukup. Why? Because of the area untuk maintain the same form tak cukup, so dia break into two. Because of, if let's say tension in plate, okay, for example we have here, this is the plate, this area yang actually resist the force, okay, because dia nak maintain the same shape so that they tak break into two. This area is not enough because kalau you cut it these two, okay, so this area you provide is not enough. Maybe if let's say you thicken the plate, perhaps it will provide better resistance from the force. And last but not least is end shear failure. This is number 4. I today started number 3. Okay, so number 4, you have to provide sufficient end distance for mode number 4 and shear failures. You see here, end distance should be original. You don't provide enough end distance, sufficient end distance for the design. What happened here, mungkin tak cukup. Probably maybe you should provide around 100 mm perhaps, but then you only provide, maybe you provide 60 mm. Okay, and distance. What happened here, dia akan the bolts will tarik sekali all this, so you punya and distance, you punya plate akan pecah lah like this. We're going to look at example from June 2019. So I go straight to the previous examination paper. So the double cover butt joint shown in figure 2 is subjected to a tensile load of 250 kN. Check whether the joint is safe by checking the strength of the cover plates, bolts and tension member. So when we are checking when we are checking the strengths, cover plates we are checking the shear. So bolts we are going to check shear and bearing, and tension member, cover plates. Okay, so cover plates. So tension member is actually the plates itself lah. Maksudnya member plates. Okay, so member plates also we're going to check for shear. Right, so there is 4 things that we have to check. So when you are checking, you must make sure that the bolts in shear does not exceed this value, and bolts in bearing does not exceed this value, and plates in tension, meaning tension member, your member plates and cover plates, the shear will not exceed the value of 155. First, we need to check bolts in shear. This is the limit, so you must make sure that the value that you calculate, the actual one, will not exceed the permissible. The formula again, if you still remember when I teach you in part 2, the stress is equal to force divided by area. Force, here you see, okay, the force that pulling out the plate is 250 kilonewton. So I convert it into Newton. That's why I times 10 power of 3. And then the area, so the area, you must know the actual area in stress for bolts. So for bolts, the actual area in stress is the cross section area of the bolt. This is 24 mm. When you calculating the area, so I use the pi r square lah. Pi times r, when the bolt's diameter is 24, so the radius become half of it, so 12 mm, power of 2. And then why I times 2? Because there is 2 cover plate. Because of this is double shear, so double shear, that's why you times 2. When you times 2, okay, senang cerita macam mana nak cakap. Okay, so because dekat bawah dekat sini yang in shear, okay, here yang in shear, so that's why you have to times 2. And I times, so kita kira half of it so half of it, we are only calculating half of it. So because of there is 6 number of bolts, times 2 because of double shear, and times 6 because of there is 6 numbers of bolts. And then bolts in bearing, again we have to check with the permissible bearing, which is 250 yeah. Okay, we have to check, so make sure it doesn't exceed this 250. So when you calculate this one, the answer is 46.052, so it is lower than this, lower than this 80 Newton over mm, so it means safe. And then bolts in bearing, check the permissible bearing, 250. So again, the formula is force divided by area. Force is 250 times 10 power of 3, same. Okay, and then the area for bearing, you have a plate. Plate here is the one that is tension member, meaning the member plate lah. So member plate, the thickness is 25 mm. You have, for example, I lukis untuk satu bolt dulu lah. For 25 mm, so your bolts will be inside here. Okay, the one that in contact with the surface of the plate is actually this area, right? That's why 24 mm because this is the diameter of the bolt. Okay, and then you have to times the thickness of the tension member ataupun member plate. Okay, and then you have to times 6 because we have 6 number of bolts. Okay, 6 numbers because here we have 6 of it, so that's why I times 6. 59.444, which means it is lower than permissible bearing stress, is safe. Third one, we have to check the tension in cover plates, and the fourth one, the tension in member plates. So first, mana-mana you buat dulu is okay. Okay, so first I check the tension in cover plates. Permissible tensile stress given in the question is 155. 155, this is your force again. So area for this, okay, for example, so you're going to cut here. You're going to cut this one and take the cross section out. So I have to draw based on that. 3 numbers of hole. Width of the member plate is 200. As I said previously, the area that in tension for plate is this area. This is the area that going to maintain the shape of the plate, so that it doesn't change because of the force acting on it. 250. And the thickness for the cover plate is here, you see. Where is it? Okay, cover plate. 250 times 20. So 250 is this one. 50 mm, 20 mm is the thickness. Here it is 20 mm. So you're going to calculate the this area that I shaded. 250, you have to minus. So because of there is 3 hole that size 27, okay, mm. Here also 27 and 27. So you have to minus this 250 minus this minus this minus this. So you will get the width of the plate without the width of the hole. So that is the width of the shaded area. Okay, and then you have to times the thickness, which is 20 mm. So because of the thickness of the plate, we nak dapatkan area, and then you have to times 2 because of there is 2 cover plate ataupun double shear. So that's why we have to times 2. The value that you have here is 36.982, which is lower than the permissible tensile stress, means it is okay or safe. And then for the tension member plates, it's also the same tension in member plates. Sama juga. How are you going to calculate it? 3 hole that size 27. Okay, and the thickness for the member plate is, where is it? 25 mm. So 25 mm. 25 mm. Here it is 250. 250 minus 3 times 27. So you get the width that I shaded here, and then you have to times the thickness of the plate, but you don't need to multiply it by 2 because this is member plate. So member plate, you only have one here, which is in the middle. Okay, so this is 2 member plates that you're going to connect together. You only times it by 1 ataupun leave it like that lah. No need to times by 2. Okay, so you get the value of 59.172, which means it is lower than permissible tensile stress. So it is safe. I still have to teach you this one, although that previously there's never question like this ever included in the final exam. But if let's say if it's ever that is going to be included later on, a simple tension member of grade 43 steel fabricated from 75 times 15 mm flat bar and the force resisted is 125. So determine the number of bolts required assuming they are 22 mm diameter and operate in double shear. Determine the size of the splice plate required to transfer this force across the joint in the main member. Allowable stress. So what's the difference between this example and the past question that I show you here? This one, everything given, so you just have to check the strength of it, whether it can resist the force or not. Okay, but for this example, you have to design how many bolts required. Here they minta cari determine splice plate. Okay, so the question asks you to determine the size of splice plates and number of bolts. The one that the tension member or member plates, okay, the size is 75 mm and the thickness, so since they operate in double shear and the thickness is 15 mm. Okay, so this is the member plate. The cover plate should be on top of it lah, maksudnya ada atas ni lagi cover plate but this question asks you to design the cover plate. Ini adalah 75. Oh, dia tak nampak. This is 20 what again? 15. This is 15 mm. 75 is the member plate width and the thickness is 15 mm. We need to design this and it acts as a tension member. Okay, and the bolt size is given in the question, 22 mm diameter. In double shear, capacity of one bolt, because we need to find how much force that one bolt can resist. If it says here that given allowable stress as bolts in shear, it is 80 Newton over mm square. So we're going to design it to be the maximum. It can resist as much as 80 Newton over mm square ni. Same one, stress equal to force divided by area. The permissible stress, because we're going to design for the maximum, is so 80 Newton over mm square, equal to force is the Fs, is the capacity for one bolt, shear force lah for bolts in shear, and then you divide. So as what I explained previously, so area for bolts in shear, it should be the diameter of the area of the bolts lah. If it say that the diameter of bolts is 22 pi r square, okay, and then 12 mm power of 2. Since it's act as double shear, so you have to times with another 2. Okay, but we don't know how many bolts that's needed. This is for one bolt capacity, but it act in double shear, so atas dengan bawah. So that's why you have to times by 2. You take this one, so pi times 12 mm power of 2 times 2. Okay, so you can get the value of Fs, which is shouldn't be 12, should be 11, because that is the diameter. Diameter of bolt is 22, so the radius should be 11 lah. 6081.234 Newton. So in kilonewton, it should be 60.821 kilonewton. Right, since double shear capacity govern the number of bolts required is, because of this is for one number of bolts, because you going to resist as much as 125 kilonewton. One bolt can resist as much as 68.821. So how many bolts that you need to resist 125 kilonewtons? Obviously that the 125 kilonewton you have to divide by 60.821. 1 kilonewton because of, okay, tulis balik, one number of bolt can resist 60.821. Okay, so how many number of bolt that you need to resist as much as 125? Obviously, if you want to find this one, you're going to divide 125 divide by 60.821. So the force is W divided by Fs, which is the shear force. W is 125 kilonewton. You divide by 60.821. You're going to get 2.055. There is no takkan you nak provide 0.055 volts. Okay, so we just going to round it up to 3 numbers. So you need 3 numbers of volt. Takkan you nak pakai 2 because you cannot round down. This is the minimum number. So we provide more. So 3 numbers. You must round it up. Okay, kalau you dapat for example 2.000001 sekalipun, it is 3. Okay, because of this is by numbers, takkan you nak provide half of volts pula. To find the size of the splice plate required to transfer this force across the joint and main member. So you need to find the size of splice plates. Member plates, we already have the size, which is 75 mm times 50 mm, but for splice plates we need to design for it. As a joint is double shear type, force in each splice plates is clearly 50% of 125. So what does it mean is, so for example this one is 125 force that pull it out. So you have 62.5 half of it and 62.5 half of it, because this is splice plate. Ada dua, okay. 62.5 means that 125 kilonewton you have to divide by 2, so you dapat 62.5 kilonewton. This is force acting on one splice plate. We need to find the area of the splice plate. What you need to do is, plate can resist as much as 155 Newton over mm square, but right now the force is only 62.5. So what is the suitable area that you need to provide that can resist as much as 155 Newton over mm square? We use the same formula, which is stress equal to force divided by area. Stress here that can be resisted by a plate is 155 Newton over mm square. Okay, the force is 62.5. Okay, this one in kilonewton, so we need to convert into Newton. To convert it into Newton, so power of 3. So this is the area that we need to find, because this is the area that, okay, for example, okay, so you have a plate, so we need to find this area. So this is the area that you're going to find last, because this one is area in shear for plate. When you calculate, you will get area equal to, you will get 403.226 mm square. So 403 to be precise, 0.226 mm square. Okay, so this is the area. So this area is actually consists by, if you look at you punya plate, so this is the area that in shear. Okay, so the total area for this is 403.226. We need to find the thickness. We fulfill the question, because the question asks you to find the size of the splice plate, bukannya area. So size ni maksudnya berapa size dia. For example, size tu macam for member plate 75 times 15, so that is the size. So we need to find that for splice plate. Since our tension member, which is the member plate, width there is actually 75. Okay, for splice plate it should be the same width as member plate. Width there should be 75 mm also. To find the thickness, so you have area equal to 403.226 mm square. This one times this one, 75 mm minus dengan the width bottom ni kecil sangat. Okay. The width of the hole. Okay, you have to minus the width of the hole and then you times the thickness. Okay, so area should be width darab dengan, I cannot use width, later you confuse, I use B times T. So B should be 75 mm lah. So B is 75 mm. So since the area that the whole area will not be included in the area in shear, so you have to minus 24 mm diameter of hole. So this is 24 mm. Okay, since in the question is not given, you know that when the size of diameter of bolt 22 mm, so the hole must be plus 2 mm from the size of the diameter, must be bigger by 2 mm. Okay, we need to calculate this. So 75 minus 24, so you will get 51. So 51 T equal to 403.226. You will get 7. Tak tempat nak tulis dah. So become 7.906 mm, which is, so takkan you nak letak thickness is 7.906, so you will round it up to 8 mm. Good. Okay, so this is the value. Okay, so this is in a very comprehensive way of explaining lah. Okay, we can finally design this. The splice plate should be 75 mm times, so this is the size size of splice plate. Two numbers because of top and bottom there is a splice plate. Okay, and the diameter and the bolts, since we calculate that we need 3. Okay, we need 3 numbers of bolt, so for one side it should be 3 numbers of bolts, should be 6 lah for both sides, so that's why it becomes 6. And 22 mm diameter, this one given in the question, the size of bolts. Okay, other than that, we also need to, if the question asks you to design, then you need to design for each distance, spacing and distance. So we're going to use the formula again. So minimum spacing should be 2.5 mm times the bolt diameter, and maximum spacing should be 14T. So 2.5 times 2.5 times bolt diameter, and maximum should be 14T. So minimum bolt pula spacing. So should be 2.5 diameter. So 2.5 diameter of bolt is 22 mm. So it should be 55 mm minimum. Okay, and the maximum spacing is 14T, 14 times T. So thickness for splice plate is 8 mm. Okay, and thickness for member plate is 15. So we pick the lowest number because dalam question, dalam example it says that the lesser the thickness, pick the thickness that is less than. Okay, so 14T times 8 mm, 112. 60 mm spacing is between 55 to 112. Okay lah. And distance and edge distance, the minimum edge and end distance is 1.25T. So this is the formula, minimum and the maximum is 11T constant, 1.25T. D is diameter of hole and E is, okay, 11T constant. 1 point minimum H and end distance is 1.25T. So maximum kita tulis dulu sebelum kita lupa. H distance is 11T constant. 1.25. So D here is diameter of hole. D is diameter of hole. So the diameter of hole is 24 mm. Because bolts is 22, so hole must be plus 2 mm. You just times the 24 mm. You will get 30 mm. Okay, and maximum H distance is 11. So times with T, so the T is the minimum thickness of plates, which is 8 mm, and you times with constant here. Constant should be square root 275 divided by Py. So square root of 275 divided by so Py, we're going to take here plates in tension. So 155 Newton over mm square. So 155. We get 1.332. So times 1.332 here. Okay, so 117.216 mm. 117.216 minimum and H distance. So here the minimum is 30. Here it is provided 50, and also it does not exceed the maximum, which is 117.216. So okay lah. So this is the design. Types of steel connection, which is welding. So the process of welding consists of heating and melting steel in and all around the gap between the pieces of steel that are being welded together. So you have two pieces of steel, so you're going to connect it to get it together. So you will heat and melt steel, the gap between the two steel. Okay, the two main types of welded joints are, we have fillet welds and butt welds. We have two types. First, we look at butt welds. So this require edges of plates to be prepared by beveling or gauging. You need to bevel it, meaning kena what we call it, like saya ingatkan dia macam ni, maksudnya you kena bevel ni. So this is the process of beveling. So you kikis, bukan kikis, you kena cut the steel to be like this or gauging, ataupun you korek dia keluar lah. So this preparation and the need to be careful alignment when welding make the butt weld generally the more expensive of the two, because you need to do some preparation before you can weld it together. So for the purpose of strength calculation, butt welds are treated as parent material. For example, allowable stress for the weld are the same as those for the connected plate. Allowable stress untuk welding sama dengan allowable stress plate ni. How much the plate is, the allowable stress for the plate is going to be the same for the welding. Okay, so the steel for welding that connect these two together also the allowable stress going to be the same. Maksudnya dia parent material, benda yang sama. So here we have single V, single U, single J and single bevel. We have a fillet weld, so no special preparation needed to strengthen the welds is calculated on the throat thickness. So the allowable stress depends on the grade of steel of connected parts, and it is 115 Newton over mm square for grade 43 steel and 160 Newton over mm square for grade 50 steel. So depends by the grade of the steel lah. Okay, so the size of the weld is specified by minimum length of the weld. For example, the strength of 8 mm weld grade 43 steel. Grade 43 steel is 8 times 0.7 times 150 equal to 644. For example, each millimeter of this length of this weld is capable of carrying a load of 644 Newton. Okay, I'm going to explain on this first, then later I will explain on this part. So first we need to know where is the throat thickness and where is the leg length. The leg length should be this one. If you cut it here, because leg length, it should be curved like this, right? Because when you have a diameter, so it should be, the leg length should be like up to here, okay? But we don't want to calculate the leg. We already have the leg length, but what we want is, we want to cut it into, not anymore like this. We want to cut it here. So we want this value. How much is the throat thickness? So this one we call it as throat thickness. Okay, so how are we going to calculate that? Okay, so we need throat thickness. Throat thickness. Okay, so here you know that it is 45 degrees. Oh, okay, here is 45 degrees. Okay, so to get the throat thickness, so you know that sine 45 degrees is equal to, it should be opposite of the degree that we're calculating. Okay, so opposite there is throat thickness. Good night. Divide by leg length. Alright, so throat thickness is equal to THR. Sine 45 is 0.707, okay, times with leg length. Okay, so you will get the value of throat thickness. Alright, I'm going to explain on this. So if let's say you want to calculate when you do welding for 43 steel, for example, okay, you know with the formula of stress equal to force divided by area. Okay, so the allowable stress is 115, meaning that it can resist as much as 150 Newton over mm for every 1 mm square area. So the force, we are trying to find the force. So the area should be, you are trying to find the areas. The area here, you're going to use the throat thickness. Okay, so 0.707. So for example, if the fillet weld is 8 mm, meaning the leg length is 8 mm, so 7.07 times 8 mm. Okay, so you will get the value of the force. The value is 650.44 Newton for every millimeter. Because of this 0.707 is the throat thickness, not the area, because if you want to calculate the area, so you have to calculate overall area of this triangle. Okay, baru dapat area, but this one you only have one side of it, which is the throat thickness here. Okay, meaning for every 1 mm length of weld, meaning the weld should be like panjang ke sana. Okay, so for every 1 mm weld, okay, it can resist as much as 650.44. So salah ni, 650 tak tepat. We are done with here.